From the launch of rockets to the balance of your bank account, math is everywhere. It's the language of the universe, describing everything from the smallest atom to the largest galaxy. But what happens when this universal language gets lost in translation? In 1999, a tiny math mistake caused NASA to lose a $125 million spacecraft. In 1983, a misplaced decimal bankrupted a major bank. And in 1940, a miscalculation destroyed a bridge. These aren't just numbers on a page, these are real-world consequences with real-world costs. Today, we're exploring the most expensive math errors in history, and how they could have been avoided. Buckle up, because when math goes wrong, things can get really interesting. Picture this: September 23, 1999. The year 2000 is approaching, and amidst the Y2K frenzy, NASA is attempting a groundbreaking mission. The Mars Climate Orbiter, a marvel of engineering, is on its final approach to the Red Planet. Its mission? To study Mars's atmosphere and climate, paving the way for future human exploration. But something goes terribly wrong. Instead of gracefully slipping into orbit, the spacecraft plunges too close to the Martian surface. It disintegrates in the thin atmosphere, becoming another piece of space debris orbiting the sun. What should have been a triumph of human ingenuity becomes a $125 million cosmic oops. So, what happened? How could a sophisticated space agency like NASA, with some of the brightest minds on the planet, make such a costly error? The answer, it turns out, is surprisingly simple: a conversion error. You see, NASA engineers were using the metric system, the standard for scientific measurements worldwide. However, Lockheed Martin, the company responsible for building the orbiter's navigation system, was using the imperial system, feet, inches, and pounds. Now you might think, isn't that obvious? Surely someone would have noticed. But in the complex world of aerospace engineering, with thousands of components and millions of lines of code, a small discrepancy can easily slip through the cracks, and slip through the cracks it did. The consequences were immediate and irreversible. The orbiter, designed to function with metric measurements, received faulty data from its navigation system, which was speaking a different mathematical language. This led to a miscalculation of the spacecraft's trajectory, sending it on a collision course with Mars. The loss of the Mars Climate Orbiter was a stark reminder that even the most brilliant minds in advanced technology can be brought down by a seemingly insignificant error. It underscored the importance of clear communication, standardized units of measurement, and rigorous cross-checking in any scientific endeavor. But beyond the financial loss and the setback to our Martian exploration plans, the incident highlighted a fundamental truth. Math is a universal language, but it only works if everyone is speaking the same dialect. Now let's shift gears from the vastness of space to the complexities of finance. In 1983, a seemingly insignificant typographical error, a misplaced decimal point, triggered a financial earthquake that shook the very foundations of a major banking institution. The First National Bank of Chicago, a pillar of the financial world, found itself teetering on the brink of collapse, all because someone missed a keystroke. It's a cautionary tale that proves, even in the world of high finance where numbers reign supreme, human error can have catastrophic consequences. Here's what happened. A trader at the bank was responsible for entering interest rates into the system. Now, we've all been there, right? Staring at a screen full of numbers, our minds prone to wandering. But in this case, a momentary lapse in concentration had monumental repercussions. Instead of entering an interest rate of 8.5%, which is already a significant figure in the world of finance, the trader accidentally punched in 85.0%. That's 10 times the intended amount. Now you'd think such a glaring error would be immediately flagged, that alarm bells would start ringing, right? Unfortunately, no. The erroneous interest rate, a ticking time bomb nestled within the bank's complex algorithms, went unnoticed for days. And with each passing hour, the bank hemorrhaged money, its financial lifeblood seeping away into a digital abyss of miscalculation. By the time the error was discovered, the damage was done. Millions of dollars had been credited to the wrong accounts, throwing the bank's balance sheet into complete disarray. The financial fallout was immediate and severe. The misplaced decimal point wasn't just a mathematical error, it was a public relations nightmare. Customers panicked, lawsuits were filed, and the bank's reputation, painstakingly built over decades, lay in tatters. The First National Bank of Chicago, once a symbol of stability and financial prowess, became a cautionary tale, a stark reminder that even in the age of computers and sophisticated algorithms, human oversight is not just important, it's essential. From the depths of space to the intricacies of finance, we now journey to the realm of engineering, where precision is paramount. The year is 1940, and the United States is celebrating a marvel of modern engineering, the Tacoma Narrows Bridge, a ribbon of steel and concrete stretching across the Puget Sound in Washington state. This elegant suspension bridge, the third longest of its kind at the time, was a testament to human ingenuity, connecting communities and showcasing the power of engineering to overcome natural obstacles. But just 4 months after its grand opening, a seemingly impossible event unfolded before the very eyes of a stunned public. The bridge, designed to withstand the harshest elements, began to sway and undulate in a gentle breeze. It wasn't supposed to do that. Bridges are supposed to be steadfast, unwavering, symbols of strength and stability. But the Tacoma Narrows Bridge on this fateful day decided to defy expectations. As the wind picked up, the gentle swaying transformed into a terrifying dance. The bridge twisted and rippled, its steel girders groaning under the strain of forces engineers had failed to fully comprehend. And then, in a dramatic climax captured on film for posterity, the bridge succumbed to the unseen forces at play. The Tacoma Narrows Bridge, once a symbol of human achievement, crumbled into the waters below, its broken spine a stark reminder that even the most meticulous calculations can be undone by the capricious whims of nature. But what caused this catastrophic failure? The answer lies in a phenomenon known as resonance frequency. Resonance frequency is the natural frequency at which an object vibrates when disturbed. Think of a wine glass shattering when a singer hits a particular high note. That's resonance frequency in action. Now, the engineers of the Tacoma Narrows Bridge had considered wind forces in their calculations, but they failed to account for the bridge's inherent resonance frequency. The wind, blowing across the bridge's surface, created vortices, swirling patterns of air that exerted a rhythmic force on the structure. This force, coinciding with the bridge's natural frequency, amplified the oscillations, turning what should have been minor vibrations into catastrophic undulations. The collapse of the Tacoma Narrows Bridge is a sobering reminder that engineering is not just about crunching numbers, it's about understanding the complex interplay of forces and anticipating the unexpected. It's a testament to the power of nature and a humbling lesson in the limits of human understanding. From the depths of space to the intricacies of finance and the monumental scale of engineering, we've seen how even the smallest mathematical errors can have astronomical consequences. These aren't just abstract calculations gone wrong. These are real-world events that have shaped history, cost millions, and in some cases even cost lives. Math is a powerful tool, a language that underpins our understanding of the universe and our ability to shape the world around us. But like any tool, it must be wielded with precision, care, and a healthy dose of respect. Because when math goes wrong, the results can be truly disastrous. What do you think is the worst math mistake in history? Or have you ever made a calculation error that cost you money? Let me know in the comments below, and let's continue this exploration of the fascinating and sometimes terrifying consequences of miscalculation. Math is powerful, but when it goes wrong, the consequences can be disastrous. What do you think is the worst math mistake in history? Or have you ever made a calculation error that cost you money? Let me know in the comments. And if you found this fascinating, don't forget to subscribe for more mind-blowing math stories.